Hey everyone, welcome back to the channel. Welcome to another video, and thanks for joining me here for another one. So as I say in every video, make sure you go ahead and you're up to date with all of our videos, because there are videos that I've made in the past and we build on those ideas and concepts. So sometimes you may get lost if you don't know what I'm talking about, because I've covered a topic in a previous video. So again, the links will be in the description, so that way you can check out the playlist and get caught up from where we are today. Now in today's video, we're still gonna focus on the networking piece, because again, there's a lot of things that make this thing called the internet actually work. And it's really, really cool. For example, I want you guys to tell me in the comments, what is YouTube's IP address? Can anyone tell me? Well, I can tell you right now, it is certainly difficult for me to tell you what YouTube's IP address is. I have no idea. And not only that too, us as humans, we're not very good at memorizing numbers and spitting out 32-bit values. It's not something that we're naturally good at. So of course, we have a service called DNS. And DNS is very, very important because it translates all these names that you and I know, because we're very good at knowing names. YouTube.com, Facebook.com. Matter of fact, do people still use Facebook? Maybe that's an old guy thing. I don't know. Anyways, the point is, all these websites have to translate into a 32-bit address. And in today's video, we're gonna learn all about DNS and how that actually works, which is a very, very important process in this whole entire thing called networking, which brings this video right to your screen. So really, really cool. Now guys, before we jump into things, of course, if my videos actually help you out and provide a lot of value, make sure you give me a like for the video, as it helps the channel grow. Make sure you go ahead and subscribe to the channel while turning on your notifications, so that way you're notified whenever I upload new videos to the channel. And lastly, of course, share this video with a family member or friend, so that way they can learn all about tech. And one last thing, guys, as always, make sure you check out the description, as all the latest and greatest information is listed there, along with links to any of the tech series that we do, or even the engineering series as well. So take a look at that. All right, guys, with all the housekeeping out of the way, let's head over to the desktop and let's learn all about DNS. See you guys there. Hey everyone, welcome to the desktop, and welcome to the next video in our series, especially when we're gonna learn about networking. And of course, we're gonna learn all about DNS. Exactly what is DNS? Well, DNS. That stands for Domain Name Service. As you guys understood earlier in the video, we humans are not good at memorizing numbers. In fact, actually, if I were to tell you, hey, go to a particular website, and I give you a 32-bit address, and remember guys, if you've seen my previous videos on networking, you should know what a 32-bit address is by now. But essentially, that is what's happening when it comes to you typing in websites or looking to communicate with other computers somewhere out there in the network. You have to give it an IP address. So when I tell you guys, hey, I'm interested in going to youtube.com. Oh, and by the way, make sure you look for Acosta E.T.F on youtube.com. Don't want to miss that. Oh, and subscribe to the channel as well. Definitely want to do that. So anyways, if you are looking for youtube.com, there is a specific 32-bit address for this. So we don't know what this address is, because of course we're terrible at memorizing addresses, especially 32-bit numbers. So we use this DNS server, and I'll just put a nice little arrow there. So this DNS service, we will ask it, hey, we are looking for youtube.com. Can you give me the IP address for youtube.com? And then the domain name service will go ahead and it will provide us with that 32-bit address. So I'll just make it up and say it's 8.8.8.8. That's just an example, but again, that's not exactly what youtube.com is, and we'll go through an example so that way you can see that. So let's scroll down a little bit here and let's talk about what happens when it comes to DNS, and we'll walk through the steps so that way you guys can see all of it clearly. But before we do that, I do want to bring in a nice little screenshot that we have here, and this screenshot should seem very similar from prior videos. So here we are, guys. This is our network details for my Windows machine, this very computer that I'm using in order to record this video and bring this to YouTube so that way you guys can watch me. This IP address here, we already talked about it in previous videos. So again, if I were to take a look at what I have over here, you guys can see that I have an IP address of 192.168.1.49. I have a subnet mask 255.255.255.0. And then, of course, in previous videos, we talked about what the default gateway is, which remember is your router. The DHCP server, remember, we did a video on that. That is also the router 192.168.1.1. And then lastly, this is the last part that we just talked about, which is, hey, we need a service to be able to translate these IP addresses that we see here with actual names. Because you and I, again, we remember simple things like youtube.com, google.com. Those names are interesting to remember. And of course, we're not going to memorize an IP address for every single website out there. It's just humans are not wired that way. And again, the DNS server is that service that allows us to translate that name back to an IP address. And what you're seeing now here is that there is a DNS server that actually lives in your router. So I can just say router over here. And as you're seeing, guys, a router in your home network is responsible for so many things. Not only does it have a DNS server that is running on there, but it also has a DHCP server that runs on there that gives out IP addresses. It is also the local and common devices to all network traffic happening in your network. So meaning whatever devices you connect to your router always has that default gateway of the router. So meaning it has to communicate with the router first in order to communicate with any other device in the world. And then of course, right, as we talked about, this IP address here was given out by the DHCP server and also as well the subnet mask. So you're now starting to see how important a router is in your home. And it's funny because these little devices that we have, I usually see people throw them in closets and not really, put too much attention to them and really abuse them. And then they wonder why they have poor internet service in their house. And I can create another video on that, but your router does so much. So it's really, really important that you invest in a good router that can handle all the tasks that it needs to do. So that way you can have a good experience in your home when it comes to browsing the web, because of course you want to be able to watch me with no problems. So again, subscribe to the channel for more. Before I jump into things real quickly on this DNS server, you now, with all my other videos, know entirely this whole thing here as far as the network connection details. You know how to pretty much read this entire thing and understand what is happening. And congratulations, you guys now are experts, I would say, when it comes to IP addressing. Most folks don't know this information, but you guys now do. So keep on watching for more useful information. So anyways, moving forward now, if you guys want to actually take a look at this, how this looks like in the Linux world, because again, this is the Windows world. So with our Linux machine, you can see that we have the same DNS, and of course it says IPv4 DNS, and it gives us an IP address of 192.168.1.1. And I use the nmcli command in order to see this. So if you guys are interested in what command I actually ran, here it is in the bottom, nmcli connection show, and then the name of my interface. And of course, the name of my interface is system space, and that's what that backslash is for. And then it's called ENP0S3. Now, your interface name may be different than mine, but just replace the system space ENP with your system interface and go find what is called the IPv4.DNS, and you can see all that information on there as well. All right, great. So we have now seen what this looks like from a Windows perspective. We now just seen what this looks like from a Linux perspective. So let's go ahead and minimize this and go back to our open board. And let's actually go into details now of what is happening when it comes to this DNS server and all the steps that it takes in order to make this internet thing possible. So let's say step one. What happens in step one? And we will call this the client request. Now, computer one wants to go to youtube.com. So let's say www.youtube.com. So we type in www.youtube.com in our favorite browser, whether that's Chrome, Brave, you name it, Edge. Pick your favorite browser. Firefox, doesn't matter, but it all works the same way. So we type it into our favorite browser, and the next thing that actually happens is that the computer goes ahead and checks inside of what is called cache. It checks its own internal cache to see if, hey, do we have this saved? And essentially, cache is just temporary storage that may or may not have the information stored from a prior inquiry before. So let's say, for example, you want to go to youtube.com and you've done this before in the past. All the computer has to do is say, hey, have I seen this before? It will go ahead and check the cache. So if it's in the cache, then essentially we take what's from cache memory and bring it back to the computer. And immediately we're done. That's how fast this is. It's that quick because it is able to pull data from what it has seen in the past. Now, let's say, for example, it doesn't find anything in cache. So if it doesn't find anything in the cache within its internal memory inside of the computer, and of course, again, it says if no, then what it does is it actually sends a request over to the next person down the list. And that typically is called the DNS resolver. Now, your DNS resolver is typically your router. Your router is what holds this information. And again, this is where your DNS IP address comes into play. So your DNS resolver is our router. And again, if we scroll up again, we see here that our DNS server is 192.168.1.1. So let's put that down over here. So it's going to ask our resolver 192.168.1.1. Now, guys, remember in our last video, we talked about different ports and how we communicate with different programs within those ports. So when it comes to DNS service, you're always going to see a port 53. And by the way, fun fact, port 53, because it's a DNS server, that's actually why AWS calls their DNS service Route 53, because it runs on port 53. So fun fact, as you start learning all these little bits and pieces of information, you start connecting the dots. I think that's also really cool. So anyways, back to our example. If yes, meaning, hey, we found it in our internal cache, which is our temporary memory inside of the computer because we've looked at youtube.com in the past, then we basically pull from there and we serve it back up to the web browser and it loads up youtube.com because it found that IP address. But if no, we send it to the DNS resolver, and that is 192.168.1.1, which is our router, and we send it over port 53. So at this point, it is at our DNS resolver or our router. We're asking it for information here. So let's go ahead and say step 2, DNS resolver. So again, just like you saw in step 1, and this is how simple this is, the router is going to check cache. So it's going to check its internal memory and say, hey, have I seen youtube.com? And guys, this is how simple a cache is. In fact, actually, I should have probably said this in step 1. But it's as simple as saying, hey, I have a name and I have an IP address. So when I say, for example, YouTube, and let's say, for example, has an IP address of 6.6.6.6, this is how simple a cache is. It basically looks in an entire cache and say, hey, I'm looking for YouTube. I found YouTube in my cache. I see the IP address. Let me just give this IP address of 6.6.6.6 back to whoever's asking me for it. And that's it. That's how simple a cache works, to be quite honest. There's a lot more to it, but oversimplified way, that's exactly how it works. So anyways, back to our step 2, the DNS resolver. So our router checks its internal cache, like you're seeing here as an example on the right-hand side, that maps a name to an IP address. So it checks the cache for youtube.com. If it finds it, so if yes, we're going to send the information or the IP address back to who was asking for it. And remember, who was asking for it was computer 1. And specifically, it was the browser. So remember, it can be Firefox, Chrome, whatever your favorite browser is. That is why a DNS server is so important that is running on your router, because if your computer does not know the IP address for a specific website, it will then ask the next person down the list, which is the DNS resolver, which of course is going to be typically your router at home. And the beauty about this is, let's pretend you have 50 computers in your home. The likelihood of somebody else in the past asking for youtube.com is very high. And especially if you have kids like me who always want to go on YouTube and check all these websites out, somebody in the house had to have asked for this website because it's so popular that the router will store, say for example, youtube.com in its cache. So when I go looking for it, it loads up very, very quickly because again, it's inside the internal memory of the router. Now, let's say, for example, if you don't have kids or some obscure website that you haven't visited before, that is going to be our second option now, and that is if no. So what happens if it's a no, if it can't find it in its internal cache? That means now that we're going to talk to what is called the root server. Now, in step 3, where we go look at the root server, this is when your resolver, the resolver or the router is going to ask this root server and says, in this message, where can I find .com domains? Now remember, our computer asked for www.youtube.com. And so the root server doesn't necessarily know the IP address for youtube.com, but it does know who runs the .com domains. So now the root server points the resolver or your router to what is called the TLD server, which leads us now to our step number 4. See, this whole entire process is not that bad to understand. So let's say step 4, and that is our TLD server. So in this step now, you have your resolver. It asks the TLD service, or should I say the TLD server, where is youtube.com? Now the TLD server doesn't necessarily know the IP address of youtube.com, but what it does know is the authoritative name server. And that one is an interesting one. And again, we'll talk about exactly what that is. But the TLD server, it points to the authoritative, and we'll just say auth for short, but authoritative name server, which leads us now into step 5. All right, so step 5, authoritative name server. So now in the authoritative name server, this is where your resolver, and remember, that's typically a router. So again, keep in mind your resolver happens to be some router out there in the network that is handling these requests for you and sending it back to your own router in your own network. But again, your resolver, which again is a router out there in the network, asks the authoritative server. And again, this is the server that actually holds the records for youtube.com. And it says, what is youtube.com? Now, the server typically provides a response, and the response is going to be the final response, which is the IP address of youtube.com. And it can be something like 142.250.36.26. Just made that up, but that could be an example. And again, since it provides this information, it goes back to your resolver. And then what happens is that your resolver, which is some router that is out there in the network, it goes ahead and communicates back to the router that originally asked in step 4. So again, the resolver in step 5 goes back to, and keep in mind, the resolver is the router. So the router, the final router that finally got the information, communicates back to the router who asked the information originally, which was from step 4. Then that router gets the information and it sends it back to the previous router, which asked for step 3. Now that this router got the information, and we can go back to this resolver, which is this router, it goes back to the router in step 2. And then of course, the router that's in step 2 finally communicates back to computer 1. And that in a nutshell is exactly what is happening whenever you're asking for a DNS request. If you have, for example, a website and you don't know the IP address for it, this whole entire process happens, which is really, really cool. And in fact, guys, I'm going to take you through an example where you can actually see this is actually happening in real time, which is really phenomenal. So let's break this down so that way you can actually see what is happening. So let's head over to my Linux machine. Oh, guys, I almost forgot. There was actually something that I wanted to tell you before we head over to our Linux machine. So if we scroll down to the last one here, remember when I said the authoritative name server actually responds back? There's multiple messages it can respond back with, but I do want to point this out because it's going to be important when we look at in the Linux world or even in the Windows world, same thing. But when these servers respond and they have the IP address, they typically respond with different type of record names. And I forgot to mention this, and this is very important because you have to know what those records are. Not all of them, but we will touch two of them that are very, very important. And we can say record. And by the way, when it comes to this 32-bit address over here, it's going to be an A record. And an A record is an IPv4 address. So that is the typical responses that we get for an IPv4 address. And when we do our example, you will actually see that. And the other record that I'll talk about, record quadruple A, this is an IPv6 address. So these are the two records that are going to be more important. Now there's other ones that are also important as well. But in order to make this video a little bit simpler, we're just going to focus on those two records. And specifically, the one that we care about is going to be an IPv4. So with that important information out of the way, let's head over now to the Linux world and see these steps 1 through 5 actually in practice. All right, guys, so here we have our Linux terminal. And one of the things that we're going to do is we're going to leverage a command called dig. And dig allows us to see these DNS lookups, which is really awesome. And if we don't add an extra flag on here, which is the plus trace, what happens with the plus trace flag on there, it says, hey, as I look through my DNS inquiry, so again, let's step through these 5 steps here. So as you can see here, remember in step 1, we check our internal cache that's internal to the machine. And if it's a yes, then we automatically have a response sent back to the machine. And again, we load it up very, very quickly because we already saved it in our temporary memory, which is our cache. And if no, it goes ahead and asks the DNS resolver. So the DNS resolver, of course, is our router. So the next step is it says, hey, DNS resolver, which is our router, check your cache to see if I have an IP address for youtube.com. And so if it's yes, it actually returns the response back to the computer immediately, which is our browser, of course. And if no, go ahead and check the root server. So by you adding that trace flag on there, essentially what you're telling the DNS resolver, which is the router, hey, I don't want you to check your cache. We're going to go through the whole entire steps of 1 through 5 so I can see everything in real time. And if you do take out that trace, it actually says, yes, go ahead and use those caches and you'll see a much faster response. So let's go through that example together. So we're going to go through steps 1 through 5. And we're not going to use the cache feature, which is what that trace is. And then, of course, we're going to go ahead and use cache so that way you can see how much faster it is. So let's go ahead and type in www.youtube.com. And let's hit enter and see what we get. All right, so that was a lot of output. And I think it's probably better if we were to actually pipe this into a less. So that way we can control the output on the terminal. So let's go ahead and rerun this again. All right, great. And just like that, I can easily control the output and we can walk through this together. So here we are at the top and you can see that we're doing a trace on www.youtube.com. And the first things that you're seeing here, and remember, let's go ahead and bring up our steps again so we can walk through this together. But the first thing that you're seeing is our root servers. So let's head back to our board here and let's go ahead and look at our steps. And remember, this is step 1, which is the client request. So this is our computer asking our DNS resolver where youtube.com is. So remember, because we did trace, trace says, hey, I don't want you to look at the cache at all. So what happens? We are looking at our DNS resolver, which is our router. And remember, our router is 192.168.1.1. And we're doing that on port 53. So with the first step out of the way, which is asking the router for this IP address, because again, we couldn't find it internally. And why? Because we disabled the cache. You should already know that by using the trace feature. So now we're asking the router, which is our step 2, hey, where can we find this youtube.com? And again, we've completely disabled the cache with that trace feature. So that leads us to our second option here, which is if no, you ask for the root servers. Well, what are the root servers, you may ask? So let's go ahead and take a look at the output. So here is the output. And again, this is essentially your steps 1 and 2 combined. So essentially, we asked the router, which is our DNS resolver, and you're seeing here 192.168.1.1 phenomenal, and you're seeing port 53. Remember, that is also very important. So it's asking for the root servers. And what do you know? You have root servers A, E, G, K, M, H, F, B, L, C, J, I, and D. Those are all of our root servers. And we received that response by our router on port 53. And it took 13 milliseconds in order for that to happen. Now, guys, you want to know how fast 13 milliseconds is? I mean, this is how incredible this is. There is 1,000 milliseconds in 1 second. So that response alone only took 13. You still got a whole bunch of milliseconds left in order to just even hit 1 second. That's how fast this stuff is actually happening. So back to our board now. You saw the outputs for steps 1 and 2. Let's go now to step 3 because now we have our root servers. We know what they are. And so essentially, the router that asked for the root server is now asking the root server, hey, where can I find the .com domains? Now that root server points to the TLD server and it sends that information back to the resolver, which of course happens to be the router at that level. So as you guessed it, let's head back to the Linux world now and see where can we find those TLD servers that knows where they can find the .com domain. So here we are at our Linux output again. So if I were to scroll down here a little bit more, what do you know? Those are all of our TLD servers. In fact, actually, you can even see the name TLD built into it. So you can see KFMJI, so on and so forth. These are all the TLD servers that you're seeing here. And the really cool thing about it is you can actually see how this all traces back together. So again, the TLD servers, we received that response back from the root server, and it looks like the root server is what responded. And might I add, specifically, it was the G server that responded. So that happened to be actually the third one here in our list. So the G server actually responded with all the TLD servers. And by the way, if we take a look at this response here, this is the IP address of that G server. And of course, you guessed it, this happens on port 53. And by the way, all of this happened in 58 milliseconds. And remember, there is 1,000 milliseconds in a second. So this is happening very, very quickly. So back to our board again, which of course our root server pointed to our TLD servers. We finally got that response of what the TLD servers are, which goes into our step 4. Now our resolver, which is the router at that level, goes to the TLD servers and says, hey, where is youtube.com? And the TLD server doesn't necessarily know the IP address, but it does know the authoritative name server, which happens to have all of these records. And it points to that server that holds the record. So let's head back to the output and see that. So here we are in our output. And if I were to scroll down here, you can see that there are 4 servers that YouTube actually manages. And it's NS1, 2, 3, and 4. So ns1.google.com all the way down to ns4google.com. So again, our TLD server told us what that was. And which one was it? It was this h.g TLD server. So if we go back up a little bit here, you can see that this TLD server was the one that responded. And it says, hey, you have 4 authoritative name server, and this is where the records are held for youtube.com. And by the way, the IP address of that h.g TLD server is 192.54.112.30. And by the way, you guessed it, this service runs on port 53. And all of that happened in 34 milliseconds. Now let's head back to the board and take a look at the final step, which is step 5. So here we are in step 5, and we finally reached the authoritative name server. And this is the server that holds all the records for youtube.com. And again, it's going to give us our IP address. It's going to tell us what record it is, and it's going to tell us some other information as well. So let's head over to the output and compare and see that all of that works out. So here we are, we're back at our Linux output, And what do you know? Here is the final response, which of course is going to be our authoritative name server. And it's going to give us exactly what we need in order to find youtube.com. Now I'm going to focus on just the A records, of course, because we just talked on those two. So again, we're going to skip the first one, which is youtube.com. We're just going to focus on the A record, which is this column that you see here that says A. And what did we say A was? We go back to our board. A is an IPv4 address. So here we are back at our Linux output again. And so our IPv4 address, because we have multiple servers that handle all the requests for youtube.com, you have 142.250.217.206. That is one of the IP addresses for one of the servers that handle the requests for youtube.com. Now remember, youtube.com is a very popular website, so it is not uncommon for us to see all of these outputs. Now the other thing that I'll point out real quickly, and it is this 300 over here. And what is that 300, by the way? So that 300 is TTL. So let's go back to the board and talk about what TTL is. So if I have a TTL, which equals time to live, so I have a time of 300 seconds in order to live. So that's what that actually means, 300 seconds. And that 300 seconds, of course, equates to 5 minutes. So essentially what we're saying that every single step along the way, if we go back up here, and we say to ourselves, okay, well, our DNS resolver, which is our router, right, at every single step of the way, step 2, step 3, there is a different router or a different resolver, and each one of these has their own cache. And so in order to make sure that our cache is not stale, meaning we have old data, right, because that IP address can change at any given time, in order to make sure that that data is not stale within the cache of each one of these resolvers at each different step, we put what is called a TTL, or a time to live, and we say, hey, you have 300 seconds or 5 minutes to make sure that this data is valid. After 5 minutes, the data is no longer valid, and it's up to the resolver to go ahead and ask for the new IP address in order to update its table for the latest and greatest youtube.com IPv4 address. And so that is exactly what this 300 means, and that's exactly what time to live is. So if we look back at the output again, you can see here that we have 300 in order for that TTL to exist. And of course, you have youtube.com, which is an A record, which is an IPv4 address, and that is 142.250.217.206. And again, who did we receive this information from? We received it from ns3.google.com, which is the authoritative name server that Google manages. And remember, there's 4 of them here. So we actually got this one to respond. And the IP address for that authoritative name server is 216.239.36.10. And of course, DNS runs on port 53. Now here's the interesting thing. Look at how long it took to respond. 24 milliseconds. So now I want you guys to actually look at how fast caching actually helps us, because if you are constantly going on youtube.com and the IP address doesn't change for 5 minutes because the TTL is 300, let's say for example, it could be the same IP address, but if it isn't, you have 5 minutes to make sure that that information still stays the same. Essentially, let's run this without trace now and see what the output looks like, and you can see the big difference. Now again, let's use our tools here, because I am not the best person when it comes to math, but of course this is going to be easy math. This response took 24 milliseconds. This response took 34 milliseconds. The next one took 58 milliseconds. This one took 13 milliseconds. So let's go ahead and add that up. And it was 129 milliseconds total for this whole entire response to happen. Now let's see how quickly this works by leveraging cache. So let's go ahead and quit out of this. And let's do the same command as before, but let's go ahead and get rid of the trace. And let's just do dig www.youtube.com, and let's pipe that into a list and see what we get. All the same information is literally here, meaning we got to the end, which gives us all the IP addresses. It gives us the A record, it gives us different TTLs. So we have a TTL of 154 seconds. So meaning we actually requested for the latest and greatest IP addresses of YouTube.com in the past, but now the information only has 154 seconds to live until the next request is sent out. And if you actually look at the request here, so again, our computer asked our resolver, which was step 1 going into step 2, and it asked our server, which is our router, hey, what is the IP address of youtube.com? And of course, it asked 192.168.1.1, which is our router, and it asked it on port 53. Remember, that's where DNS resolves. And it sends a response, as you can see here. It sends a response back immediately, and it took 6 milliseconds. Now, because this data was here before and it was stored in cache, we don't have to go through all the 5 steps. We basically just stopped at step 2 because we asked the router, which is our resolver, hey, do you have the IP address for youtube.com? And sure enough, somebody in my home has already asked for this in the past, which is why I have all the IP4 addresses here, and I still have 154 seconds of TTL, or time to live, in order to make sure that this information is actually the latest and greatest. So look at the difference there. 6 milliseconds versus 129 milliseconds. That is the big benefit of why you're seeing now cache is so important, because we can accelerate how quickly we can get our answers, and you're seeing the big difference there. 129 milliseconds without using cache versus using cache is 6 milliseconds. And just like that, guys, that's all there is to DNS. Great job for following me this long. So welcome back, everybody. By now, you guys are pretty much experts in understanding how DNS works and what happens in those 5 steps in order to make such an important service works. So as always, guys, remember, us humans, we're not good at memorizing 32-bit IP addresses. And in fact, actually, between you and I, guys, I'm not even good at memorizing birthdays. I have to put them in my calendar. That's how bad this is. But I have to put them into my calendar to make sure that I call these people on the day of their birthdays. So again, this service is so vital because it memorizes what those IP addresses are. And all we have to do is say, hey, I want to go to a specific website called youtube.com, and it will go ahead and translate that address for us, so that way we can actually make it there correctly. So guys, that'll do it for this video. Go ahead and sound off in the comments to let me know if you guys have any questions on DNS, or maybe you want me to tackle a specific subject on the next video. I'm always reading the comments, and I'm curious to hear what your thoughts are. So again, guys, thanks for watching. Love you and appreciate you all. And before we head out, make sure you give me a like for the video if this video has helped you out. Go ahead and subscribe to the channel and turn on your notifications so you're notified when I upload new videos to the channel. And lastly, share this with a family member or friend so that way they can learn as well. Oh guys, and before I head out, one last thing. If you don't want to wait for my next video, YouTube thinks that you'll like this video popping up on screen. So go ahead and give that a watch, and I'll see you guys in the next one.